Welcome to Spring LIB.
Okay, so we're doing chapter 23, problem 81. So it says a non-conducting sphere of radius R2 contains a concentric spherical cavity of radius R1. The material between R1 and R2 contains a uniform charge density rho E. Determine the electric potential V relative to V of R equals infinity equaling 0 as a function of distance R from the center. So for A, we want R greater than R2. Okay, so excuse me. Since we know that the potential is 0 at infinity, the potential outside the spell or outside of the shell follows that as a point charge. So we already know that this is given by 1 over 4 pi epsilon naught total charge over R. Okay, but we don't know in terms of the total charge, so we got to write out this in terms of rho E. So this is now 1 over 4 pi epsilon naught times R, and now the total charge is given by rho E times the big volume minus the carved out small volume. Cool. And if we simplify that, this comes out to being rho E over 3 epsilon naught R2 cubed minus R1 cubed all over R. Cool. So this is for R greater than R2. Moving on to part B, it asks now for R1 less than R2. So for this, we need to use Gauss's law, where we have the surface integral of E dot dA. And if we draw a Gaussian surface just outside of the shell, then we should see that this equals the charge enclosed over epsilon naught. And we know this is given by, since the spherical symmetry of our problem, E times the surface area of a sphere, which is 4 pi r squared. So now we can just write this as 1 over 4 pi epsilon naught charge enclosed over r squared. But what is the charge enclosed now? We've got to figure that out. So we have 1 over 4 pi epsilon naught r squared. And now the charge enclosed is, again, similarly to what we have here, but instead of being the big radius R2 outside, it's just as a function of R. So this is rho E times the volume enclosed from R minus the carved out no charge volume. Cool. So this looks very similar, I'm guessing. And you'll see that it comes out to being an answer very similar. So we get the electric field to be rho E over 3 epsilon naught R cubed minus R1 cubed all over R squared. So this is what the electric field is like, but we're still trying to find the potential. So if we're trying to find the potential, we can take the potential at R and subtract off the potential at the surface. And this is given by the integral of E dot dl. And this is the same as integrating from R2 to R negative E dr. Okay, so let's do this integral now. So we have negative integral R2 to R, rho E over 3 epsilon naught R cubed minus R1 cubed over R squared dr. Okay, so this is a fairly challenging integral. Not actually, because we can just simplify this, pull out rho E over 3 epsilon naught, integral from R2 to R, and we should have R prime minus R1 cubed over R prime squared, dr prime. Okay, I'm going to add a new page here. So this was VR minus VR2. And this equals the result of our integral, which was negative rho e over 3 epsilon naught. And now we have 1/2 r squared plus r1 cubed over r, all evaluated from r2 to r. Cool. So now we can just add on VR to both VR2 to both sides. This cancels that out to where we get V of r equaling rho e over 3 epsilon naught. And now we have r2 squared over 2 minus r squared over 6 minus r1 cubed over 3r. Awesome. It was a lot of work to get there, but we made it. Lastly, there's part C. And part C wants us to do it for 0 less than r less than r1. Okay, so inside the cavity there's no electric field, so the potential is constant. And it has a value that it is on the cavity boundary. So that means VR1 equals the cavity boundary. So from this, we can just plug in the VR of r equaling r1, which we did up here. And that gets us rho e over 3 epsilon naught r2 squared over 2 plus r1 squared over 6 minus r1 squared over 3. Simplifying this as rho e over 3 epsilon naught. We still have r2 squared over 2, but now these two r1 squared terms can combine, and this becomes minus, we have 1/6 minus 3/6, so this becomes minus 2/6 or minus 1/3 r1 squared. Cool. If we simplify this out, we get rho e over 2 epsilon naught r2 cubed minus r1 squared. This is VR1. Awesome. We made it to the end barely.